2-4 is on complex numbers. So it's going to seem like we're taking a slight intermission from quadratic equations and quadratic functions to talk about complex numbers. What we will be talking about are things like imaginary numbers. All right, so if we think this through, x squared is 16. That means that x could equal a positive 4 or a negative 4. So because 4 squared is 16 and negative 4 squared is 16. So remember the inverse of square root is squaring something and vice versa. So in this case, we have something squared. By taking the square root, that undoes it. So there's two answers. Now, by definition, something has a square root because a number times itself gives me that number. So in this case, negative 4 times negative 4 gives me positive 16. But if I think about that in a negative sense, so what multiplied by itself, whatever it is, gives me a negative 9. Well, there is no scenario for that because a positive times a positive is positive, and a negative times a negative is positive. But if we have two different signs, that's the only way to get a negative number, but that's not the same. Like positive $3 in your account is totally different than negative $3 in your account. So this is where imaginary numbers come into play. So what we say is that x squared equals negative 1 times 9. Okay, we can take the square root of both sides so that we're left with x. We still could have a positive or a negative. And we can also split this up to say negative square root of 1 times square root of 9. So then I can do a little bit of algebra there. The square root of 9 is 3. And here's your new concept. The square root of negative 1 equals I. So anytime you see a negative under the radical, it comes out of the radical as I. So we're going to talk a little bit more about imaginary numbers, but imaginary numbers come from negative under the square root.